Today we're going to talk about solving linear inequalities and graphing them. You need to keep in mind that I will be going a little quickly through this video, but because it is a video, you are able to pause it, rewind it, and make sure that you're able to copy down anything that you may need. So please keep that in mind when going through this video. The first thing I'm going to do is define what a half plane is. Because we are going to discuss that a lot in this particular lesson. A half plane is a region containing all points that has one boundary, which is a straight line that continues in both directions infinitely. And we will show you that here in a second as well. Steps for graphing inequalities. You need to make sure that you know this so that you can graph these inequalities correctly. And if you follow these step-by-step rules, you will be able to do this without an issue. The first step is to get the formula or equation in slope-intercept form. And of course, we know that we do that by solving for y. Step 2 is we're going to determine whether it is a solid or dashed line, and we're going to talk about how you determine that here in a second. Then you're going to determine whether to shade above or below the line. This is a very easy step. There's two ways to do it, and we're going to discuss both ways. But one of the ways is to test the points. Step 4, if the test points are true, shade the half plane containing it. And then step 5, if the test points are false, shade the half plane that does not contain the point. So these are very quickly and easily how you would graph an inequality, which is very similar to graphing a linear equation, which we've been doing. The symbols that we need to make sure that we know, that we've discussed before. Anything that is greater than, you're going to shade above. Okay? So if it's greater than or equal to, you're going to shade above the line. And then you're going to shade below the line anytime you have a less than sign, less than or equal to. Now we need to look at what type of line we're going to have. You have either a dashed line or a solid line. If you have in order to have a dashed line, you're going to have a less than or just a greater than sign. So just a normal sign that does not have anything to do with being equal to will be a dashed line. Okay. And then you're going to have a solid line anytime you have equal to related to your inequality. So if I have less than or equal to or greater than or equal to, then you will have a solid line. All right, so we're going to look at this example. We have x minus 2y is less than or equal to 6. Step 1 told us that we need to make sure that we get the y, or put it in slope-intercept form, which in order to do that, we have to solve for y. So the first thing we're going to do is try to get y by itself. So I'm going to first subtract x. Sorry. Let me make sure I have the pen ready to go. So the first thing we're going to do is subtract x from both sides. Minus x minus x. Once we do that, we know the x's cancel out on this side, so we have negative 2y. And then on this side, we cannot combine the 6 and the x, so I'm going to rewrite this as negative x plus 6. Now I bring my inequality sign down, and it does not change right now. It's still a less than or equal to. Now I'm still trying to get this y by itself. The only thing that's over there with it is the negative 2. So I'm going to divide both sides by negative 2. Those will cancel. Then I'm going to divide each term on the other side of my equation by negative 2. So I have y, negative x divided by negative 2. I have a negative divided by a negative. Now, also, what number is in front of this x? That's right, you guessed it. There is a 1. So I'm going to rewrite this as 1/2 x. I'm able to do that because I have a negative and a negative. Two negatives make a positive. Okay, and I always want this to be a fraction because that is my m. and my m is my slope. My slope is rise over run. Then I have 6 divided by -2, which gives me -3. So I'm going to write -3 right there. Now, there's one tricky thing about this inequality sign that we have to remember when we solve inequality equations. If we divide by a negative number, does anybody remember what we have to do? That's right, you guessed it. We have to switch the inequality sign and make it greater than or equal to. So now that we've done that, we're going to now we're ready to graph it. So we know that I'm going to have what type of line am I going to have because of this right here? It is greater than or equal to, so I'm going to have a solid line. So I am going to go through my steps of graphing a line just like I have before. -3 is my y-intercept, so I'm going to go to -3 and make a point. And then my slope is 1/2. So that means my rise is 1, my run is 2. So I'm going to go up 1/2, up 1/2, up 1/2. Then I'm going to go in the opposite direction as well, just because I want to make my line as accurate as possible. Down 1/2, down 1/2, down 1/2, down 1/2. And now I'm going to attempt to make a straight line here. And I have the line part of my graph. Now, because it is a greater than or equal to, I'm supposed to shade above the line. So ideally, I would think that above the line is in the region that contains 0, 0. So what I can do to make sure that I am correct is I can test it. I can put 0 in for X and see n for Y and see if that makes a true statement. So I'm going to do that. Is 0 greater than or equal to 1/2 times 0 minus 3? Will that be a true statement? I'm looking at this point right here and trying to see if that's going to be true. Well, 1/2 times 0 is 0, and 0 minus 3 is -3. So I have 0 is greater than or equal to -3. That is a true statement. So this is the region that I'm supposed to shade. And so what this means is that when I'm looking at as far as what is my answer, that means that this region that I just shaded in are all of those points are the solutions to this particular inequality, meaning that all of those points will meet the requirements to make that a true statement. Okay. Well, look at example 2. I have 2x minus y is less than 4. All right. So again, I have to first get this in slope-intercept form. So I want us to get the y by itself. So I am going to first make sure I'm on pen. I am. And I am going to subtract the 2x from both sides. Minus 2x, minus 2x. Those cancel. And on this side, I have negative y is less than 4 minus 2x. I'm going to write that as negative 2x. And what type of 4 is that? Is that a positive or a negative 4? It's a positive 4. So I can just do that. Now, I have negative y is less than negative 2x plus 4. Okay, I need to get rid of this negative sign, but I can't just erase it. I have to remember there's a 1 right there, so now I can divide everything by negative 1. The negative 1s cancel out. I have y by itself now. But I divided by a negative number, so my inequality sign is going to switch again. Then negative 2 divided by negative 1, I'm going to get, I want to keep that as a fraction and not just change that to negative 2 because it is my slope. So I'm going to keep that as 2 over 1x. And then 4 divided by negative 1 is negative 4. So now I'm ready to graph. I'm going to go ahead and plot my point at -4 on my y-axis because that's my y-intercept. And then I'm gonna rise 2 and run to the right 1. So rise 2, right 1. Rise 2, right 1. Rise 2, right 1. Rise 2, right 1. And then I'm gonna fall 2 to the left 1. Down 2, left 1. Down 2, left 1. Okay. I'm gonna connect those dots and try to make as straight a line as possible for Coach Russell. And that's about as straight as I'm gonna get. And now y is greater than, so, oh, I made a mistake. It's just greater than, not greater than or equal to, right? So I should have a dashed line. So I need to go through here and make sure that I have a dashed line. So I'm going to do it this way. Okay. And now I have a dashed line. Okay, I have to have a dashed line because the solution does not include the points that's on that line, and we have to understand that. But because we have y is greater than, I'm again assuming that I should shade in the region that has 0, 0 as a point. So again, that's going to be the point that I test just because I like working with small numbers. So I have 0 is less than 2 over 1 times 0 minus 4. And I can see 2 times 0 is 0, minus 4 is -4. So I have 0 is greater than -4. That is a true statement. So I do shade the region that is right here. And so what's asked is the point -4, 5, which is right here. Is that point a solution? Then the answer would be yes. All right. Now you have a worksheet that you can begin working on, and you can ask us if you have any questions.